A thin wire is wound very tightly in one layer on the surface of a sphere of paramagnetic material. Relative permeability is 1. The planes of all the turns can be assumed to be perpendicular to the same diameter of the sphere. So how they are wound? Suppose you have a ball like this. Then over the ball, for the same diameter, these planes are, so wire is wound like this. Starting from here, it is wound like this, brought from the other side of the ball, and again wound. So the radius of the ball, coils are decreasing as you move from the center to the sides. So it is wound like this. So the planes of all the turns can be assumed to be perpendicular to the same diameter. So if you take this as diameter, then all these coils are perpendicular. Their axis is along the diameter, and their planes are perpendicular to the diameter. Okay. If the radius of the sphere is r, that means the sphere on which the wire is wound, and the total number of turns is n, then the current flowing through is I. The magnetic induction at the center of the sphere is, so what is the magnetic field here? So you have actually number of planar coils placed like this on either sides. You can assume it like this. And all of them will produce magnetic field at the center. So they are actually the coils obtained by winding wire over this sphere. So what is the magnetic field here? So easy problem actually. You would go for integration. But before going for integration, you must be ready with all the tools, a sample wire and all. Okay. So we will take a coil like this. It's not a perfect circle. I'll try one more. This is worst. This is better. Okay. I'll divide it like this. Now let us imagine that it contains wires wound in one axis. Now I'll take one sample of the wire here. I will cut the ball at somewhere here. Then I'll get one sample of coil. And let its radius be A. That means this height, let it be A. And let that sample coil is, because I know the magnetic field due to the coil at a distance, mu naught Ni r squared divided by 2 into r squared plus x squared to the power 3 by 2. So what is the magnetic field produced by this coil here? And I have to then spread that coil throughout. Now let this coil be present at a distance x from the center. Radius of the coil is A, and that coil is present at a distance x from the center. I need to have one more diagram, I think, very clear. It's not so clear because I have to draw so many things at that place. So I have to have a very clear circle. I'm not getting circle. Okay. This is okay. Yes. Okay. So here I'll take a sample. I'll take a sample wire here. I'll cut down it here and then take a sample. Because when I cut the whole sphere, I'll get some turns of the wire like this. Okay. So this is a coil that I have taken, and this radius is A. And that will be producing a magnetic field at the center of the whole sphere at a distance x from the center. So this contains some number of turns, this piece. And let that piece that I have taken has a thickness dx. So when I cut the whole sphere here into a small piece, I'll get a thickness x, dx. Now, if I join the two ends, and if this makes some thickness, if I join the two ends here like this, they make an angle here, because that piece will have a small thickness, and let this be d theta, this angle, and let this be theta. So the thickness dx here, which I have taken for this thickness coil, subtends an angle d theta at the center, and this circle, the edge of this circle is making an angle theta with the x-axis. Now, how many turns will be present in this piece of the coil? That's what you have to find out. Now, as you move from here like this up to this point, so when you move semicircularly in the semicircle from here like this up to this point, you get n number of turns because there are total number of turns n. That means in 2 pi r by 2, that means half circle, you get n number of turns. In dx length, how many number of turns? That is dn. So number of turns in this part is here. Number of turns in that piece is pi r path contains n number of turns. Pi r means half circle from here to here. Then dx length has got how many number of turns? That is dn. So in this circular wire like this, which is taken a piece from here, from this piece, there are dn number of turns. They come out of this piece here. So this radius is A. What is the magnetic field due to this coil here? Okay. dx can be replaced as r d theta because finally you have to integrate it in terms of theta. So I can write this when I join it to the center, I get a d theta here like this, d theta, and this is r. So you can take dx is equal to r d theta. That is another formula. Okay, so what is the magnetic field due to this coil here at O? Magnetic field dB is equal to, mu naught Ni r squared by 2 into r squared plus x squared to the power 3 by 2. Mu naught n is dn, that is number of turns coming within this. Mu naught n I r square, its radius is a square, r square divided by mu naught Ni r square divided by 2 into r square plus x square. X is same. X is here written. X square to the power 3 by 2. This is dB. Now you have to substitute for dn. dn says dB is equal to mu naught. dn is n by pi r. N by pi r dx. dx can be written as r d theta. So r d theta. So we have substituted dn. N by pi r r d theta dn I a square. So this part is remaining by 2 into this one. A square plus x square is nothing but r. So this is r. This is r. So x square plus a square. Pythagoras theorem. That is r square. So I can write 2 into r square to the power 3 by 2. So this is r. That is nothing but r. Okay. So the formula gets simplified very easily. R squared to the power 3 by 2. So what is dB? dB, magnetic field due to a small sample piece in the whole ball. dB is equal to, so R gets cancelled. Then what else? And I think we have to replace some sorts of A, I think X, okay. A is changing with the X. That has to be replaced. We have to replace it as X is r cos theta. Yeah. And A is r sin theta. Here you can replace A. Sin theta is equal. You can take it as sin theta here. Opposite side divided by hypotenuse r. A is equal to r sin theta. So dB is equal to mu naught by pi. Pi remains. Mu naught by pi, n, total number of turns. Mu naught is over, n is over, pi is over. I, a square can be written as r square sine square theta, because A is r sine theta, here you'll get it. A is r sine theta, r square sine square theta, A square is over, divided by 2 into, this is r square to the power 3 by 2, r cube. So that implies dB is equal to mu naught n, they're all constants, I. R will get cancelled, 1 R will remain. Pi R, I think that is correct. Mu naught n I by pi R. Oh, d theta is missing here. D theta, I have not written this, d theta. Mu naught n I by pi R. 2 is missing. 2 is missing. Or, oh no, from where did we get 2? 2 is in the formula. Mu naught n I by, yes, 2 is missing. Then r square, sine square theta d theta. I think everything is over. Mu naught by pi n I r square among r, 1 r is remaining, that is written. So this is over. 2 is written, sine square theta d theta. So what is the net magnetic field? Net magnetic field will be obtained by considering all such small pieces of wires here, starting from theta, this theta, 0 to theta is equal to pi, 180 degree. Then it will cover the full turns. So B is equal to, take the constants out, Ni by 2 pi r integration 0 to pi sine square theta d theta. That implies B is equal to mu naught Ni by 2 pi r, mu naught Ni by 2 pi r into 0 to pi 1 minus cos 2 theta by 2 into d theta. So B is equal to mu naught Ni by 2r. Finally, you have to express it as mu naught Ni by r. Then remaining x you have to write. Okay. Mu naught Ni by 2r. This 2 can be taken outside by 2. Then 1, integration of 1 is theta minus cos 2 theta. That is integration is sine 2 theta by 2. Not by 2. If you differentiate this, you will get cos 2 theta into 2. Yeah. Yes, sine 2 theta by 2. Yes. That is correct. Now integration limits 0 to pi. Now that implies mu naught Ni by 4r into 4 pi r. Pi is missing. Pi, because there is a pi here, 4 pi r. Now, if you put the limits, upper limit is pi, lower limit is 0. So pi, then sine pi and sine 0, both will be 0. So this will be minus 0. So final answer is mu naught Ni by 4 pi r. B is equal to mu naught Ni by 4 pi r. I think only 1 by 4 is, so what the K or something, what is that? Yes, x into mu naught Ni by r. X into mu naught Ni by r. Ni by pi r, isn't it? Oh, mu naught Ni, x into mu naught Ni by r. Then where is pi? Okay, 1 minute. Here 1 pi we have got. Yes, pi gets cancelled. Pi gets cancelled. Yes, mu naught Ni by r. For this you have to compare. Here pi has got cancelled. So in the place of x we have 1 by 4. That's all. Thank you.